Right, so we're going to look at the third application problem, which is the volume of revolution around the x-axis. And again, just to start us off, we're just going to have a quick sketch of this just to help us visualize this. So e to the negative x plus 1 will look something like this. I'm integrating between 1 and 3, so 1 is there and 3 is there. Again, scale, we're not worried about the scale, we're just worried about what the function looks like, the shape of it, and where it's positioned on the axis. So just to recap in terms of volume around the x-axis, we're rotating it this way around. And volume is equal to pi between 1 and 3 of y squared dx. So if we continue through this and we want to find the volume of this, it's rotated around, so we find the volume is equal to pi lots of the integral between 1 and 3, y squared, so our y function is 1 plus e to the negative x all squared dx. Now we need to be careful here, before we integrate this we need to expand it out. So we expand the bracket and we get 1 plus 2 lots of e to the negative x plus e to the negative 2x dx. So now if we go ahead and integrate this, 1 integrates to x. Now 2e to the negative x, the differential of negative x is minus 1, and we divide by that, so with minus 2e to the negative x. E to the negative 2x, very similar to the previous one, the differential of the power is minus 2, so we divide by minus 2, so with 1, minus 1 on 2, e to the negative 2x, between 3 and 1. Now you can already see this is starting to get a little bit messy, is this integral. So the chances of us getting what you found with the other examples we looked at, with the previous one we got e squared minus 3 and then 1 on e squared plus 3. Sometimes with exponentials they do work out quite nicely, and the simplification is quite straightforward. If that's not the case, and this looks like this is going to be one of those cases, then leaving it in a decimal form is absolutely fine and can save us a lot of time as well. So here we go through the process of subbing our values in. So 3 minus 2 lots of e to the minus 3 minus a half e to the minus 6 minus, in brackets, so we sub 1 in, so 1 minus 2e to the negative 1 minus a half e to the negative 2. Now the thing is, normally when we've got both brackets written out like this, there's quite often terms in the first bracket that will cancel with terms in the second bracket. However, here we don't, other than the constants 1 and 3, we don't have anything like that. So what we're actually going to do here is we are going to type this into our calculators. Notice I put in the approximate sign down there. And if you type this into your calculators, you'll end up with roughly 8.49. It's going to be units cubed, so I don't need the bracket there. Units cubed, and that's to 2 decimal places. So it's a good example there of when not trying to look. You could try and simplify that. It would take you a long time for very little gain. If you start to see it becoming too complicated, a decimal answer is perfect. Just like here, if we could have written decimal answers for the previous 2 questions as well, and it would have been fine. It's just sometimes it's actually easier to leave a simplified version, and sometimes, as in this case here, it's easier to actually simplify it and type it into it's easier to type into your calculator rather than it is to simplify it.